Two numbers, that's it. Just two. The number 1 and the number 0. Together! They've built the entire digital world. This isn't a sci-fi script. This is math. It's called the binary number system, and it's the most elegant, efficient, and underestimated invention in modern history. Yeah, just 2 digits. Not even trying to reach 10. Decimals out here showing off with 0 to 9. Binary just goes, meh, I only need 2. In this video, we're going deep into the origins, the function, and the surprisingly cool applications of the binary number system. Because behind every click, every post, and every AI robot trying to sound smart, there's just these 2 little symbols, 1 and 0, doing all the heavy lifting. So, where did it all begin? Let's rewind history, way before Silicon Valley, and meet some ancient philosophers who might have been the original binary geeks. Turns out, binary isn't a Silicon Valley invention. Around 3,000 years ago, Chinese scholars used a mystical book called the I Ching, which was all about opposites. Yin and yang, light and dark, yes and no. They used patterns of solid and broken lines. Basically early binary. Each hexagram had 6 lines, either solid or broken, which is a 6-bit binary number. That's 64 combinations. It's like a spiritual Excel sheet. Enter Gottfried Wilhelm Leibniz in the year 1703. He was a philosopher, mathematician, and part-time genius. He looked at these ancient patterns and said, wait a minute, this is math. He wrote a paper called Explication de l'arithmétique binaire and officially introduced base 2 to Europe. Yeah, while others were playing chess, this guy was busy inventing the code behind your gaming PC. Why only 2 digits? Why not 10 like normal people? Well, binary is the simplest system there is. All you need is 2 states. On-off, high-low, true, false. It's perfect for machines. Ever flipped a switch? Congratulations, you've spoken binary. Decimal is base 10 because humans have 10 fingers. But machines? They don't care about fingers. They care about voltage. Either there is or there isn't. That's 1 or 0. Let's dive deeper into binary. We already know binary is base 2, which means each digit is a power of 2. But guess what? You can also do math with binary, just like with regular numbers. Let's explore. Counting in binary is like counting in decimal, except you roll over at 2 instead of 10. So after 1, it becomes 1 0, which is 2. Then 1 1 is 3, and 1 0 0 is 4. Don't worry, even robots use cheat sheets for this. Binary addition is super similar to decimal, but instead of carrying over at 10, we carry at 2. Let's try. 1 plus 1 equals 1 0. 0, carry the 1. Add it all up and boom, you've just added in binary. It's like regular addition, but with more carrying and less crying. Well, sometime. Now subtraction. Just like in base 10, if you can't subtract 1 from 0, you borrow from the next digit. Sounds dramatic, but binary keeps it simple. Binary borrowing, because sometimes 0 just isn't enough. Multiplication in binary is like decimal, but way easier. You just shift and add. 0 times anything, that's still 0. 1 times anything, you copy it, then shift and sum. Binary division? Same principle. You divide and subtract repeatedly, just like in long division. Only you're dividing by 1s and 0s instead of 9s and 4s. Don't worry, it's not as scary as your high school math teacher. Here's a cool trick. Shift left equals multiply by 2. Shift right equals divide by 2. It's like math with a remote control. Just slide your way to the answer. Let's say you've got the number 13 in decimal. and you want to turn it into binary. Here's the trick. Divide by 2 again and again, and collect the remainders like Pokemon. Ta-da! 13 in binary is 1101. It's like unwrapping a present from the bottom up. To go back to decimal, just multiply each bit by its power of 2 and add them all up. It's like a reverse treasure map, except the x is in the exponent. Quick! What's 1010 times 10? Answers! 10100. If you got them right, you're basically a digital wizard. All right, Binary Master. Now let's see how these tiny digits are used to store, process, and create our digital lives. Next up, bits and bytes. All right, time to meet the binary family. First up, the tiniest unit in the digital world, the bit. Short for binary digit. Just a single 0 or 1. 1 byte equals 8 bits. Can represent 256 different values, 2 to the power of 8. That's A to Z, emojis, colors, even cat pictures. Now let's talk about how binary becomes brainy. Welcome to the land of Boolean logic. In the 1800s, George Boole decided to give binary logic a proper structure. He invented Boolean algebra, where 1 means true and 0 means false. It's like building a computer out of pure logic. Yes, really. Boole didn't just invent logic for computers. He invented the logic your mom uses when she says, if your grades are bad and you play video games, then you're grounded. In the 1940s, Claude Shannon took Boole's math and plugged it into real circuits. He made logic gates using switches and relays, and suddenly, computers became possible. Logic gates like AND, OR, and NOT use binary inputs to create logical outputs. This is the beating heart of every digital device you own. These gates are like tiny decision makers. Combine them and you can build calculators, apps, AI, basically everything. This was a game changer. Suddenly machines could think using electricity. That's how the first digital computers were born. Yup, your smartphone's great-great-grandparent was basically a fancy light switch. Today, binary is everywhere. Your phone? Binary. Your video games? Binary. The robot vacuum that's scared of carpets? Yup, binary. Audio. It is converted to binary waveforms. Images to pixels with RGB values stored as binary. And text to ASCII or Unicode, all in base 2. Even when you type LOL, your computer sees 0 and 1. So it's basically laughing in robot language. In the future, we might not be stuck with just 1s and 0s. Meet qubits, the quantum cousins of bits. A qubit can be 0, 1, or both at the same time. It's called superposition, and it powers quantum computing. Quantum computing, where yes means no and maybe means probably. It's like dating, but with physics. So there you have it. The binary number system, born from philosophy, built with math, wired into machines and launched into the digital age. From ancient symbols to AI robots, from Morse code to Mars missions, 2 little digits made it all possible. So next time you restart your Wi-Fi router, whisper to it, "Go on, little ones and zeros, change the world again."